we might as well move on to our next speaker, who is Louise Dyson, who's from the University of Warwick, and she's going to be talking to us about some work they've recently done on schools and testing with schools. So I'll hand over to you, Louise.
Thanks, Kira. Let's see if I can get this working. Good. Yeah, so Ian gave a really nice kind of broad overview of all the many things that they've been doing. And I've chosen to focus more on one particular piece of work. So less broad reaching, I'm afraid, but hopefully still interesting. And this work was led by Tristan Lang. So all the good bits are his, and any mistakes I made are really mine and mine alone. So we've been looking at secondary school reopening strategies. So this isn't so much thinking about whether we should reopen schools, it's more thinking about if and when we do, are there kind of testing, are there things that we could do with tests that would make things better? And if you're interested in the Warwick work, there's a URL at the bottom here, and that's the kind of Warwick COVID website, which has got all the kind of different preprints and things that we've published. And this work is available as a preprint on medRxiv if you want the full details. So what was the question we were trying to answer here? So at the beginning of the year, when we thought that schools were going to go back, the government had some strategies for schools to be implementing. And the idea was that the students would have 2 lateral flow tests in the week before they went back to school. Then we would have weekly testing of students and staff. And we would change strategies from the pre-Christmas strategy, which was whenever somebody in school tested positive, all the students in their bubble were asked to stay at home and isolate for 10 days. And we were going to move to a strategy where instead, when a student tests positive, their bubble they could go home and isolate, or they could decide that they wanted to take daily tests. So every morning you would take a test, and you can only go to school if that's negative. So the reason for looking at this was partly that there was a lot of talk about how testing was going to help schools to reopen safely. And we wanted to be really clear about what the benefits were of different sorts of testing. So in particular, this kind of testing where we're moving from a situation where people would just stay at home and would not be available to transmit infection, to a strategy where if your test came back negative and that was a false negative, that you were still infected, that would in fact increase infection rates. So the main benefit of this strategy is not that you reduce infection rates, but is that more kids get to go to school. So we wanted to kind of quantify these different effects. So this is from the kind of brochure that the schools were sent about how to manage the return to school. And you can see that there are these 3 steps that I was just describing. So testing before coming back to school, weekly testing of students and staff, and daily contact testing if you are a close contact of a positive case. This is the same brochure, so you can see, you know, if my child was a close contact of a positive individual, what would I do? Well, they could just stay at home, or you could do this 7-day testing. If it's positive, the guidance is that you should take then a PCR test. And if that's positive, you do a self-isolation, and if it's negative, then you can keep going with your lateral flow tests. So we developed a model to look at this situation. So it's a discrete time, stochastic, individual-based model with a daily time step. And we have these sort of 5 year group bubbles, 200 students each. So this is supposed to be, it's like a secondary school without its 6th form. And pupils are allowed to mix randomly within their bubble. And we have a profile for how long it takes you to develop symptoms, and then how infectious you are before and after your symptoms. And this comes from data on sort of pair transmissions. In the baseline model, there's no transmission between bubbles, but we did run sensitivity to that. And we have this kind of constant external force of infection, which is essentially all the infections that might happen outside of school. And this is chosen so that at the end of the half term, about 10% of students will have had infection. We take between 12 and 31% of infections to be symptomatic. And we say that asymptomatics are between 30 and 70% as infectious as symptomatics. So part of the difficulty of making this kind of model is that there is a lot of uncertainty to a lot of these parameters. And the way we've approached that is to try and incorporate this uncertainty into our model. So by taking these ranges rather than point estimates. And also we are thinking of this model as a way of comparing different strategies. So we're not particularly saying that this precise number of people will be infected. We just want to know what happens if you do different things. So it's more of a kind of comparison strategy. Okay, so these are the 2 different types of tests. So if you develop symptoms and you go and get a test, you do a swab, so you stick a swab up your nose and at the back of your throat. And what will usually happen to that swab is that it will go for a PCR test. So it goes away to a lab and it takes a little while to process, and then you get a result. So it takes a few days. And these tests are very sensitive. And you can see that, so along the x-axis here, we have how long has it been since you were infected. And you can see that your probability of getting a positive PCR test goes up. This is as your viral load increases, and then it sort of degrades over time. But you have this quite a long tail. So the different lines here are just different assumptions about how sensitive we think the tests might be. And the dotted lines compared to the not dotted lines are about whether you're asymptomatic or symptomatic. So the lateral flow tests, on the other hand, you still do a swab. The swab is exactly the same, but the lateral flow tests are much faster. You don't need to send it off to a lab. You can get your results in maybe 15 minutes, half an hour. And what you might have heard about the lateral flow tests is that they're a lot less sensitive than the PCR tests. And that is to some extent true, but it also depends a lot where you are in your infection. So in this kind of peak viral load of your infection, you have a lot higher probability of testing positive on your lateral flow test. Still probably a little bit lower than the PCR test, but when you're at the peak of your viral load, and also therefore we think at the peak of your infectiousness, you are more likely to test positive. It's not a kind of simple multiplication of your probabilities to say that the lateral flow test is less sensitive. So out here, you might be more likely to test positive on a PCR test than on a lateral flow, but it's unclear how much it matters because you're probably not very infectious at that point anyway. Okay, so we have 5 different strategies and I've given them colors, and I intend to keep those colors throughout. So the kind of I was going to say the control strategy. The strategy where we don't do anything is in grey, and this is just a counterfactual. We have always been doing something, but this is to look at what the effects of that are. So if you just sent kids back to school and you didn't worry about them, what we were doing before Christmas was this isolation of year groups. And now we have two new strategies. One is this serial contact tracing. So this is somebody tests positive, and that means you do tests every morning for 7 days. There's weekly mass testing. So just you get tested once a week. And then we have a combination strategy, which is serial contact tracing and weekly mass testing. And for these last three, we're going to say that we test twice in the week before they return to school. Okay, so this is the kind of headline result. So here there are sort of a cloud of points for each of the different strategies, and each point is a different parameter combination. So it sort of gives you an idea of our uncertainty. And you can see that this isolation of year groups leads to lots of school days missed per pupil, and quite a range of infections, whereas all the other three strategies are squished against the x-axis. So you don't miss very many days of schools, but they do kind of extend out to the right. So the total number of infections at the end of the half term could be quite high. And now these two plots are just looking at those two axes separately. So here you can see you miss so many days more school with the isolation of year groups that we cut the axis. So the kind of proposed strategies really do reduce the number of school days that kids miss. So they have, in some sense, the desired result, but they do somewhat increase the total number of infected individuals. So you can see in grey, this is if we just didn't do anything at all, and that can go up quite high. The serial contact testing or the weekly mass testing reduces that a bit, but not as much as isolating year groups. So not as much as the pre-Christmas strategy. But in fact, a combination of both serial contact testing and weekly mass testing can be lower than everything else. So the combination strategy looks pretty good. You have low infections, you don't miss so much school, but you do have to do a lot of testing. So by the end of your 7-week half term, each student will have received on average maybe 25 tests, and you're testing 70 to 80% of your school every day. So it needs a lot of tests. So you have to buy a lot of tests, and you also have to persuade people that they want to take them. And it's just like in the care homes, it's not great to be sticking things up kids' noses every day. So that's the trade-off, really. So this is just the prevalence over time. So you can see that the serial contact testing and isolating year groups has this kind of lump at the beginning. So it's sort of less good to start with and then gets better. And you can see that the combination strategies really win, partly because they identify lots of asymptomatic individuals. So all this testing that you're doing is finding lots of asymptomatics. Okay, so that's really the summary. So the proposed straight change, if you went from isolating year groups to just doing serial contact testing, you get higher infections, but less kids off school. And a combination of the two reduces both infection rates and time spent off school, but needs lots of testing. Okay, so just to finish, these are all the people who did the work and are on the paper. I also want to thank the Warwick team and the JUNW team. UKRI for funding us. And this is the medRxiv link and a, what's it called? A thingamy. I'm sure you know what they are. QR code, there we are. Thank you. Are there any questions?
Thank you very much, Louise. There's a few questions coming in, a lot related to sort of the sensitivity of lateral flow testing. So the very first question is exactly on that. So what is the sensitivity of the model on the false negative rate of the lateral flow device tests? So presumably this is a critical parameter and one that depends on who is administering the test. So that comes from Duncan Roberts.
Yeah, so I don't have in my head the overall number, though I imagine it's in the paper. But as I say, this is really the crucial difference. So it depends a lot what you mean by false negative. So the fact is that you end up with more negatives of infected people a long time since they've been infected, but they're also less infectious. So indeed, this is a parameter that we vary in the model. And as you say, it does somewhat depend on how well you take the swab. I think I put in the sensitivity things at the end. So this is a plot that shows you, or a series of plots that show you the sensitivity of the outputs in the model to the parameters that you're putting in. So if your LFT sensitivity is lower than we said, which way around am I? Lower than we said in the purple, then you end up with more cases than you would do if it was at baseline. And you can sort of see the sensitivity of all of these outputs to that parameter. So there's a lot of stuff in the paper and the supplementary material to the paper, which sort of goes into this sort of thing.
Okay, cool. Yeah, so there's quite a few questions and I don't think we're going to get through them all. So I'll post a link to your medRxiv in the chat to everyone. So because there's quite a few questions regarding sort of sensitivity analysis, so I'll do that in case people are interested in details. So Roland Cow had a question about are the parameter estimate distributions correlated in your model? So for example, are the performance of the different tests related to each other when you look at uncertainty?
I'm going to show the same picture I just showed. Sorry. Yes, in the sense that you are some number of days since infection, and that will affect both your PCR test result and your lateral flow test result. The other uncertainties that we put in are not correlated. They're just kind of taken from the sort of uniform distributions in the parameter values.
Somebody's asked a question regarding vaccination. So would it be possible to include in the model the effect of vaccinating the teaching staff?
Well, that's an interesting question. I mean, you may have noticed that there are no teachers in this model. And that's an interesting thing to think about including. It's difficult to include these things because it's hard to know how much teaching staff transmit to children, how much children transmit to teaching staff. My guess is that it wouldn't make a lot of difference because there are just fewer teaching staff than there are pupils. And so the benefit of vaccinating teaching staff is not really to the children, it's to the staff. It's that it might reduce the number of hospitalizations of the staff. And as far as the evidence for this at the moment seems to be that teaching staff are not particularly at higher risk than other professions. That evidence is somewhat uncertain, which is why there's lots of arguments about schools and teaching. but that is the evidence that I know at the moment.
Cool, thank you. So I'm afraid we're not going to get through all these questions. So in the interest of time, I'd like to move on to the next speaker, but I will post the link in the medRxiv chat, and hopefully if that your question isn't answered there, then maybe we can try and come back to it in the panel discussion.